All right, so again, we're just going to go over the ones that were most missed. Friction is a force that acts in the same direction as an object's in motion. Hold on. So friction and same direction. Whenever you have your free body diagram, you're going to have your force that's applied. And that's going to be where your push or your pull is going to be at. Opposite of that, you could have two types of forces. Your force of friction, and then your force of air resistance. But the question's not asking about air resistance. So friction's always going to be opposite. So this one is false. Number 2, forces are in pairs that are always equal and opposite of one another. So this relates to the third law, which states for every action, which is your force, your push or your pull, there is an equal and opposite reaction. So equal and opposite, this one is true. All right, the next one that was most missed was asking about Newton's second law. So Newton's second law is just force equals mass times acceleration. So the only one that looks like it's saying mass multiplied by acceleration is B. The next one's Newton's third law. Again, that's saying that for every action, there's an equal and opposite reaction. All right, the next one. A car is driving down the road at 25 meters per second. So we're going to assume that this is a constant rate. Because it doesn't say it's accelerating, it doesn't say it's speeding up or slowing down. And the force of the motor is 1,200 newtons. How much air resistance and friction is the vehicle encountering? All right, so if it's going at a constant rate of 25 meters per second, again, that means there's no acceleration. And if there's no acceleration, that means it has a zero net force. It's in equilibrium. So what that looks like as a free body diagram is you have your force that's applied, which is 1,200 newtons. And then you're going to have two forces acting against it. The force of friction and the force of air resistance. Well, if it's a zero net force and your force applied is 1,200 newtons, what do these two need to equal? The same thing, 1,200 newtons. All right, the next one. If a baseball is thrown on Earth, it will travel in a parabolic path and eventually land on the ground. So let's draw out what that looks like. On Earth, you throw a baseball, it's going to go forward, but eventually it's going to fall down to the ground. And that happens because of gravity. What would happen if you threw the same ball in the middle of outer space? So the keyword is space. Very far away from Earth and any other planets, and why? So in space, if you were to throw a ball, it would just keep going and going and going because there's no gravity and there's no air resistance acting on it because there's nothing in space. It's just an empty vacuum. So if there's no gravity, no air resistance, it's just going to keep traveling in a straight line forever. It'll keep going and going and going, just like that Energizer Bunny. Do you remember that commercial of the Energizer Bunny? No? He has the hammer, just going and going. Anyways, never mind. Next question. There are 4 cars with different masses that are being accelerated at the same rate. The acceleration for all 4 cars is 5 meters per second squared. Which car experiences the smallest force? So we want the car with the smallest force. Remember, force equals mass times acceleration. So that's the formula you're going to be using for all of these. These are all in kilograms, so those are all your masses. All you have to do is multiply them by 5 meters per second squared. And then you get your force. So for car A, 1,000 times 5 is 5,000 newtons. Sorry. For B, 1150 times 5, that's 5,750 newtons. For C, 980 times 5, that's 4,900 newtons. And then for car D, 1070 times 5, that is 5,350 newtons. And then for the smallest one, that would be your 4,900. That is car C. All right, the next one that was most missed, an object weighs 185.5 newtons on Mars and has a mass of 50 kilograms. What is the acceleration due to gravity on Mars? So the key word here is acceleration due to gravity. Anytime you see something that says acceleration due to gravity, all that means is it's just gravity. We're looking for gravity on Mars. It's not on Earth, so it's not 9.8 like we always say. It's a different planet. It has a different gravity. We need to find it. We know the weight and we know the mass. Our formula equals weight equals mass times gravity. If we're solving for gravity, we're just going to divide mass by both sides. So gravity just equals weight divided by mass. That's all we need to do for this problem. So gravity, weight divided by mass. Our weight was 185.5 newtons. And we're going to divide that by 50 kilograms. If you did this correctly, your gravity would be 3.71 meters per second squared, which is D. An unlucky bird flies into a plate glass window. The bird sadly did not make it. Compare the force felt by the plate glass and the bird. So again, this is third law. For every action, there's an equal but opposite reaction. So they're the same force, but they're not the same acceleration. They're not the same impact. So it's going to be the same force, but because of the mass of the window and the mass of the bird's going to feel it more. All right. A train has a mass of 50,000 kilograms and a force of 3,705,000 newtons. What is the acceleration of the train? So again, we're looking for acceleration. We know our mass. We know our force. Our formula is force equals mass times acceleration. If we're looking for acceleration, we're just going to divide by mass. So acceleration is force divided by mass. Our force is 375,000 newtons. Our mass is 50,000 newtons. 375 divided by 50, that's going to give you 7.5 meters per second squared. Make sure you have your formulas written down, ready to go for tomorrow. Because again, a lot of math, not a lot of math, but a few questions that are math problems. All right, the next most missed question. You suddenly slam on the brakes of your vehicle while moving and your body continues to move forward and the seatbelt catches you. Why does your body continue to move forward? That's Newton's first law. An object in motion stays in motion. Remember, objects are lazy. Whatever they're doing, they just want to keep doing it. They don't want to change unless something makes them change. So because of that laziness, we call that inertia. Newton's first law. All right, the next one. A soccer player kicks a ball. What is the force of the ball on the player's foot? Again, that's third law. Remember, for every action, there's an equal but opposite reaction, which means there's an equal but opposite force. So it'll be equal in size but opposite in direction. D is the answer. All right, we're almost done. I just have 3 more to go over with you. A spaceship traveling in a straight line through an emptiness of space still requires a constant force to keep it moving. No, it doesn't require any force. Because it's in space, there's no friction, there's no air resistance, there's nothing acting on it. So if an object is already moving in space, it'll keep moving in space. So this one's false. All right, the last 2 I'm going to go over. Which term means resistance to motion? So resistance is kind of like opposite. Motion would be your push or pull. So which one's opposite of your push or your pull? That's friction. Friction's going to be opposite to your motion, to your push or your pull. Which term means resistance to a change in motion? So what that means is it doesn't want to move. It's like trying to get you out of bed in the morning. You don't want to get out of bed. So that's inertia. That's Newton's first law. All right, so again, those are the most missed questions to the review. Your homework tonight is just to catch up on all of your missing work, get it all turned in, and then go ahead and study for this test. You can do the review over and over again 20 times. Even if you get 100 and you still want to play one more time just before the test so that way you can refresh everything in your head, I encourage you to do so. If you have any questions, stay on. If not, you are free to go.